Okay, we are going to learn how to factor. So every time in math, when we learn something, we learn to undo it. So like we learn addition, then we learn subtraction. We learn multiplication, then we learn division. So we learn distributive property, and we are going to learn factor. So these are all opposites of each other, okay? So you can always check your work by going the opposite way, taking your answer and doing the opposite to it. So the opposite of distributing is factoring. So that's what we are going to focus on today. We're going to take it slow, be patient, um, write everything down, use your calculator, and we'll get through this, okay? So it says we have a little bit of warm up. We have 3 problems just to practice distributing. So remember with distributing, we are going to multiply coefficients and add exponents. So when we factor, we're going to do the complete opposite of that. Instead of multiplying coefficients, we're going to divide coefficients. Instead of adding exponents, we're going to subtract exponents. So you're going to see that in just a little bit. Okay, so we'll look at this warm up. So this is what we've done. We multiply coefficients, add exponents. So we're going to distribute the 7x squared into everything inside the parentheses. So we multiply 7 times 2, get 14, and we add exponents. X squared and just an x to the first power. We add the plus 1 is 3, so x to the third. Then we're going to distribute 7x squared and 4. So we're going to multiply 7 times 4. So if you need to, use that calculator. 7 times 4, 28. And add your exponents. Well, we only have an exponent on the outside, so it's just going to stay the same. 28x squared. Next one, distributing x to everything inside. So it's x to the first power. It would just be like having a 1 here. 1 times 4 is 4. X and x make x squared. That would be like 1. Remember, multiply your coefficients. 1 times 4 is 4. X times x is x squared. And then 1x times a negative 7. 1 times negative 7 is negative 7. And then we keep our x. We don't have to add anything to it. We just keep it. Okay, next one, negative 5 distributed inside all of those terms. Negative 5 times 12. Negative 60. And we don't have any variables outside, so we're just going to keep our same x squared there. And then negative 5 times a positive 2 minus 10. Yep. So in order to factor, we've got to find the GCF. GCF is called the greatest common factor. And we can actually use our calculator to find our greatest common factor. But in the calculator, they call it greatest common denominator. Because we use that whenever we add fractions that don't have like denominators. We use your greatest common denominator to change your denominator. So what this is, it divides all terms. So not just the numbers, but the variables too. All terms evenly. When being asked to factor out a GCF, think of the process as undoing the distributive property. So that's what I was talking about at the beginning. We're going to undo the distributive property. We're going to factor them. And we can actually find the GCF, or in the calculator it's called the GCD, using the calculator. So I'm going to tell you how to do that. So let's say we have two numbers. Let's say we have 28 and 24. We want to know what number divides both of those evenly. So we can actually use our calculator. So you're going to go to math right here. Go over to number and find GCD. Push enter. And you can put both of those numbers in. 28, do a comma, 24, close the parentheses. So I'm going to show you again with the calculator, but let me show you. The comma is above the 7. The parentheses is above the 8 and 9. So our GCD or GCF is 4. So the way we went there, we went to the button math. We went over to number. Write those instructions down. And go down to number 9 for GCD. And so we'll do GCD 28, comma 24. You can only do 2 numbers at a time.
Is that 9?
This, yep, yep. Mm-hmm. Yep. Math over to none. Find the GCD. Then 28, comma 24. And it comes out to equal 4.
Where's the comma at?
Above 7. Okay, so your calculator will find those for you. If you're really good at your multiplication facts, you don't have to do this, but it might be helpful just to do the checking. All right, so now we know how to use our calculator to find the GCF. So we are going to factor this example right here, 5x minus 35. So let's read the steps. Find the GCF of the coefficients and factor it out. Divide each term by the GCF. So we are going to find the GCF of your coefficients, 5 and 35. So we can put it in the calculator. So go math, over to num, go to GCF, GCD, 5, comma 35. That's 5. Yeah, and doesn't that make sense? What evenly divides 5 and 35 that they have in common is 5. So that's step 1. Find your GCF of your coefficients. Step 2, find the GCF of the variables by finding the lowest power of each variable that will evenly divide all terms and factor it out, divide each term by the GCF. So what we do is we look and see what is the lowest power. Well, we have 5x and we have 35. They both don't have a variable. So on this one, it's going to be none because they don't have a variable in common. Because what you're really looking for is a common variable. And you want to choose the smallest one. Smallest exponent. So our GCF for the whole thing is 5. So you look at the GCF of your numbers and of your variables, and you go ahead and write it. But we didn't have any variables, so that's why it's just 5. Number 3 says move the GCF to the outside and write in parentheses what is remaining after you factor the GCF. So see, I have 2 terms here. I'm going to go ahead and put 5 outside the parentheses because I am going backwards. So basically, I'm going from this back to that, from this back to that. So something's going to be outside the parentheses that would be distributed. And I'm going to divide this 5x minus 35 by the GCF. You see how 5x minus 35, I'll rewrite it, divided by the GCF, and we're going to write what's left inside the parentheses. So 5x divided by 5. Yep. Then I have negative 35 divided by 5. Negative 7. Yep. Okay, so these 2 things are equal. We could leave off the 1. We don't have to have it. So this could be or 5 parentheses x minus 7. But what we did is we went backwards. We undistributed. So if we send it in, let's go ahead and just show how this works, how we get back to our original. 5 times 1x, 5x. 5 times a negative 7. Okay. So see how this is the same thing. So this is a way of checking your work, distributing it back in. We're factoring it out, and then you can check your work by distributing back in. Okay. So it's a lot of dividing. So in order to factor, we're going to divide by the GCF and subtract the exponent. All right, so let's go ahead and go to our examples on the inside. We're only going to do this left side today. So let's work on that. Let's factor out the GCF, 10x minus 15. So step 1 says find the GCF of the coefficient and factor it out. So GCF or GCD, 10 and 15. If you're good at multiplication, you can just think about what divides both 10 and 15 evenly. And if you put it in the calculator, it's perfectly fine also. So do math, number 15, 10, comma, 15. Yeah, 5 evenly divides both of these numbers. Okay, so 5 will be part of the GCD. Now you look at your variables. Do they have any variables in common? So no variables. If they both had it, then we could divide it, but they both don't have an x, so we can't. So our GCF is just 5. So go ahead and write that out to the side. And that's what's going to go outside the parentheses. Go ahead and put it outside the parentheses. Now we take what we have that we're factoring and divide by the GCF all the way through. So divide 10 by 5. 2x. Negative 15 divided by 5. Negative 3. And we could double check it just by distributing. What's 5 times 2x? 10x. What is 5 times a negative 3? Negative 15. So we're done. That's it. So we're undoing it, and we can check it. So the next ones are a little different because we have some variables. But when we get down to these, I'm going to let y'all do some of those. Let's go ahead and go to example 2. Factor out the GCF. We have t cubed plus 7t squared minus 5t. So you would have to do the GCF or GCD of 1, 7, and -5. Is there anything in common with those? No, so it's 1. They don't have anything in common. And you can actually do 3 numbers in the calculator, it won't let you. But you can write this down so that you can try to figure it out. But then what's the lowest variable that they have in common? Lowest exponent. Yep, so it's t. So t is what they all have in common. So that means our GCF is just t. So t is the only thing that they have in common. Remember, factoring is finding what they have in common, finding the GCD, what they have in common. So t is going to go outside. We're going to divide everything by t. I'm going to rewrite this because that did not give me enough room to divide by t. I feel like I need a little bit more room, so I'm rewriting it. So divide by t, divide by t, divide by t. When you divide variables that are the same, you subtract your exponents. So it's like you're taking one away. You're going to take one away from every single one of these. So if I have t3 and t1, that's going to leave me with t2. Going back to the rule of dividing like bases, you subtract your exponents. 7t squared over t, just going to be plus 7t. Negative 5t over t, well, t and t, they're the same, so they cancel, just leaving us with minus 5. So all we did was take out a t, which meant it's the exact same as what we had with one less exponent. All right, let's go up to this one. 2m squared plus 4mn. So we want to do the GCF of 2 and 4. Oh, can't see that, sorry. So you look for what divides 2 and 4 evenly. Yes, 2. And then we needed to find our common variables with the lowest exponent. So we'll look at m first. What do they have in common? They both have m. So we can take it out because we're looking for what's in common. What's in common is just m. And then n squared and n, you take your lowest exponent there. When they both have it, you take your lowest. So n squared and n would just be n. So then our GCF, we put these together. GCF, let's see there. GCF is 2mn. Once you find your GCF, you put it out front. And then divide everything by 2mn. I'm going to go ahead and write it. It didn't give me enough room on this one either. That's our original. We're going to divide by our GCF. Oh, 2mn, not a square. And then 2mn. So you divide coefficients and subtract exponents. 2 divided by 2 is 1. M divided by n, that cancels. And then n squared over n. How many n's are we left with? Yep. Then look at your numbers. 4 over 2. What's 4 divided by 2?
2.
Yep, so plus 2. That's going to equal 2. And then what about m and n? Something over itself cancels. So that's what we're left with. M and n cancel. So this is what we're left with. 2mn, parentheses, 1n plus 2. All right, let's go to the next one. Factor out the GCF. All right. GCF of 7 and 4. There isn't one, so it's 1. So that's called prime there. What about your common variable? Do they have anything in common? No variables. Put no bar. So our GCF is just 1. When your GCF is 1 with no variables or anything like that, it's called prime. That means it cannot be divided evenly. They have nothing in common. So it's actually just the same thing. Or you can put it as prime. The only way to fill this in would be to put 1 out front and just put whatever you have inside the parentheses. That's it. We couldn't do anything. That 1 doesn't even change anything. So when you actually have a problem like this, you're just going to write prime when there's nothing in common. Yeah, no work when it's prime. Exactly. All right, go ahead and look at number 1. Now think about it. All right, so let's look. There is no coefficient, so we can't pull out anything there. So GCF, we can actually look at our lowest exponent that they have in common. What do they both have? Just x. They both have an x. So x goes out front. And we're going to divide everything by x. So whenever you do that, x's cancel. We're left with y and then minus z. So we factor out an x. When you factor, you're going to divide by your GCF, which was just x, and then you list out everything left. Let's go to the next one, GCF. We're going to start with our numbers. This one didn't have any numbers, so we couldn't factor anything there. This one does, 9 and 3. So you look at what they have in common, 9 and 3, and it's just 3. 3 will divide both of them evenly. Then we look for our exponents. So we have x squared and x. And you always want to choose the lowest one because they both have at least that. They both don't have x squared, but they both have an x. So x is part of your GCF. So that goes out front. We're going to divide everything by 3x. Whenever you divide your coefficients, subtract your exponents. So I'm going to start with this one. 9 divided by 3 is 3. X squared and x, we're going to subtract. So we have 2 minus 1 is just an x. And then we have 3x over 3x. Yeah, it's just 1. So there's a minus there, so it's minus 1. So remember, we're undoing the distributive property. So we could show how this is the same as this by distributing it back in. 3 times 3 is 9. X times x is x squared. 3x times a negative 1 is a negative 3x. Go ahead and do the next one. Look at your coefficients, the numbers out front. Okay, let's go ahead and look at this. 21b minus 15a. So we would need to find the GCF of 21 and 15. So I showed you how to use a calculator. So I'm going to show you again. So we can do GCD in our calculator. So you do math over to number, go to number 9, which is GCD, of 21, comma, 15. Comma is above the 7. Yeah, 3. So GCF is 3. And then we have B and A. They have nothing in common, so we can't do that. So we're putting 3 out front. And we're going to divide everything by that GCF. So I'm just going to do like this. So we'll divide those. 7, and then B has to stay there. It doesn't go away because there's nothing to subtract it or simplify it or anything like that. Then the other one, 15 divided by 3 is 5. And we got to keep our A also. So if you distribute it back in, you should get what we had as our problem. Whenever you distribute it, 3 times 7 is 21, and then we have a B. 3 times negative 5 is negative 15, and we have an A. So what you're required to do on all these problems is write your GCF and then write your final answer. Okay. Let's go to the next one. You always want to go from your greatest variable to your smallest variable. These are written in that form, cubed and then squared. Cubed, squared, first. This one's written in squared, fourth, and fifth. So this one we're going to have to reorganize. Well, let's go ahead and look at this. 27 and 18. So you need to do your GCF or GCD. No. 9 is the value that divides all of them equally. So we also need to look at our variable. So this is GCF is 9, and then y cubed and y squared. So what they have in common is a y squared. So this is 9y squared. And then we divide everything by 9y squared. So I do the coefficients first. 27 divided by 9. 3. So you divide coefficients and then you subtract exponents. Okay, so then you subtract those. So 3 minus 2 is a 1, so it's just a y. And then we do 18 divided by 9. It's 2. And then they both have y squared, so that cancels. So we don't need a y or a y squared or anything because we took it out. We divided it out. All right, let's look at the next one. We have 14, negative 28, and 1. They don't have anything in common except for 1. If it was just, if I marked that out and I didn't have that 1, you could look at 14 and 28. But because we don't have anything here, it's like a 1. Those numbers don't have any common factors except for 1, so we can't do any numbers there. But we can do our lowest variable exponent. So y squared, and y cubed. So they all have y in common. Yep. So y is going to be factored out. Roll it out. And then divide by y all the way through. So remember, when you divide, you're going to subtract your exponent. So it's 3 minus 1, 14y2, exactly. Because we can't get rid of the 14 because we didn't factor any numbers out. And then minus 28y, yep, because y squared and 1 make just y. And then y and y cancel, so it's just plus 1. You have to have something there. So you can't put 0, you can't leave it off, because if you do, when you distribute it back in, there wouldn't be that last term. We have to have that last term there. So that's why we have 3 here, and it matches with 3 terms up here. 2 terms, inside parentheses, you also have 2 terms. So that's how many you have inside that parentheses. All right, our last one for today. Let's look at number 6. First thing we have to do is reorganize them because you want it from greatest to least exponent. So I'm going to put the biggest exponent first. So this will be 44p5. And then minus 11p4 plus 55p squared. Then we look at our numbers, our GCF. So think about these numbers, 44, 11, 55. 11 will divide evenly. So on the 3 terms, you can only do 2 numbers at a time in the calculator. So what I could do is do BCD 44, 11. And that gives me 11. Then I could make sure that that also goes with 55. And it does, because 5 times 11 is 55. So it's 11. And then we want the smallest variable exponent. So it would have to be p squared as our smallest one. Because p squared could become p4 and p5. So that's how we know we can fix it up. Go ahead and put that out front. We're going to divide by 11p squared. So divide your coefficients, subtract your exponent. So 44 divided by 11. Should be 4. And then subtract your exponents, 5 minus 2. The next one by 11p squared. 11s will cancel. Subtract your exponents, p4 and p2, make p2. Divide by 11p squared. Yep. 55 divided by 11 is 5. Right. P squared and p squared cancel. So that is it. So let me show you. I'm going to give you an assignment, but we're not doing all of them today. I'm going to show you which ones we're going to do. You're going to keep this. We're going to finish it tomorrow. And here are the problems you're going to do. 1, 2, 3, 4, 6, 17, and 18. Those are the ones that you will do today. I'm about to pass